Engineer Rajkumar. Then sustainable development with concrete. This presentation will be given by Dr. Kalgal. Then who is our past Secretary General. Then again, the sustainability related codal provisions will be given by Dr. Raghunath, who is professor in Business College. Then finally, the role of academia in achieving sustainability development goals and provisions in new NEP 2022 as SDG 4. This will be given by our own president, Dr. Ashwath. And then the last session will be panel discussion. This is a brief about the program which we have, which we would like to present to you in the subsequent weeks. But now, just to give you some more introduction on this, this has been accredited by CPD, Engineering Council of India, and they will be giving 20 credit hours for this. So each program will be having 2 points. Then we want to, just inform the participants that at least 70% of your attendance should be there to facilitate your participation certificate and then to obtain the credit mark, the condition which has been put forth by the ECI. So please take note of it and request all the participants to set all the programs so that you can get most benefit out of this. Then just give you more information on this. This headquarter of ACC has come with nearly 8 verticals, which is generally, we know the objectives of ACC, how it can be translated. So, 8 verticals has been formed. I will just, reading out the verticals: foundation, institutes, studio, collaborations, issues and advocacy, publications, member benefits, and member development. So, under these verticals, we have this institute and issues and advocacy. These 2 is very aggressively doing. We are lacking on other aspects which we will be now taking forward, and then we will try to do our level best on the other platforms. Under the institute, this program is coming, wherein our Dr. Ajit, today's speaker, is the chairman for that working group, and our moderator Ranganath is the coordinator for the working group. This is in a brief to tell about the throw some light about this program. We may be knowing the non-destructive test and how we conduct and all that. In that, for example, for a corrosion, when you do the hostile potential measures, so you will be, probability you will be giving it is very less corrosion and moderate and then severe corrosion. Okay, something like that. How you classify in this sustainability also, you can able to in the pre-construction stage itself. The entity is done mostly on the post-construction. The pre-construction stage itself, you can able to evaluate whether it is sustainable mild, sustainable, moderately sustainable, or sustainable, or least sustainable, or non-sustainable. So much, prediction you can able to do it in the pre-construction stage itself, which you will be now coming to know by the speakers when you are attending all the programs. Now, finally, before I conclude, I would talk about today's moderator, a brief introduction of him, which you should aware of. Our engineer Ranganath has done his BE from BMS from UECE 1980, and then he has done his MTech in IIT Madras during 1982. Then he has done MS Structural Engineering in 1984 in Kansas State University, and he worked in worked 2 years in US, that is 84 to 86. Then later he came back to India, and then he's running a firm, Ranganath and Associates. As a structural consultant, he has involved in a lot of design of multi-story buildings, commercial buildings, and he has done a lot of turnkey projects. And recently, he is giving a turnkey solutions or concept of completion on the residential and commercial buildings, which is a unique feature what he is providing now. And he also served as secretary a decade ago in ACCE, and he is very aggressive implementing regarding the engineers bill NBC 2016 and bylaws. So he was very aggressive in all the professional activities. That's why I want to present today's moderator. Welcome you all once again, and over to moderate. Thank you. You tell me.
Ranganath has to unmute.
You have to unmute, I think. Mr. Ranganath, you have to unmute.
Oh. I think now you can hear me?
Yeah.
You can hear? Okay.
Sir, we can hear you.
Go ahead.
Okay. Again, thank the Chairman. Thank you, Mr. Chairman, for your welcome address, and to all your committee members for organizing this wonderful series of presentations on sustainable engineering. Friends, we are very happy today to have the presence of our National President, Dr. M.U. Ashwath, with us. I request Dr. M.U. Ashwath to address the gathering, briefly enlighten us on the ASP-SDI working group activities, and throw open this series of webinars. Mr. President.
Good evening, Ranganath and the program leader, Dr. Ajit Sabnis. Very happy to see all of you doing great work under the working group institutes, ASP-SDI institutes. As many of you know, all the ASP members know, of course, those who are not members of ASP, I request all of you to become members of ASP and be part of all our activities. We have created, as Ranganath was mentioning, we have created lots of activities, specifically the working groups on the foundation. We have working groups on institutes, working group on studio, collaborations, issues and advocacy, publications and membership. So there are many such working groups are created under ASP platform to focusedly work on the requirements of the civil engineering community in general and construction industry in particular. So the working groups are very active, and I'm very happy that one of the working groups is ASP-SDI Institutes, has mainly taken up the sustainability in construction industry under the leadership of Dr. Ajit Sabnis. They are doing a lot of work, and this activity, a series of lectures on sustainable engineering is one of the activity of one of the working groups. So I compliment on behalf of ASP-SDI HQ all the members involved in this organizing team, especially the Bengaluru Center has taken the lead, giving all the logistics support to the working groups headed by Dr. Ajit Sabnis. So that is one. Then the many other working groups like issues and advocacy is doing a lot of work and activity. As all of you know, the present day need is engineers bill, and the draft engineers bill is already submitted by the AICTE to NHRD. And associated with that, there are a lot of activities going on in the country, and a lot of issues are also evolving out of this. And the Issues and Advocacy Committee, headed by Srikanth Channel, is also doing a lot of activities. As many of you already know, many of the issues concerned with the consultants is they're not eligible to bid for some of the tenders. So there are many High Court orders and also Supreme Court order recently that all civil engineers are also eligible to compete for these services, engineering services and architectural services. So in this connection, the Issues and Advocacy Committee is doing a lot of activities and writing to all the organizations and agencies for considering the engineers for all activities on par with any other professionals. And in this connection, again, there are a lot of publication activities are also taken up by the working group on publications. They're also under the leadership of Dr. Kirna Krasu and S.P. Srinivasan. They are doing a lot of activities on publications also. So overall, Association of Consulting Civil Engineers is focusedly working with the different teams for the needs of the engineering community, especially the consulting engineering community in the country. So part of these activities as outcome of all these working groups to fight for the concerns and rights of the civil engineers, we have also formed a task force at the national level consisting of members from all the states of the country, and they're also working closely with the legal bodies and competent authorities in their region, collecting the information, and wherever there is some injustice happening to the consultants and civil engineers, wherever there is no prominence for civil engineers, where there should be. In such cases, the task force members are directly interacting with all the members, and they are working closely with all the organizations to protect the interests of civil engineering community. So all these working groups are very active, and I request all the participants present here, if you have any issues connected with the consultancy or the construction industry, you can bring these information to the notice of the association, and the association will take it up at the right platform and fight for the rights of the engineers. So apart from this, as the module coordinator Engineer D. Ranganath mentioned, knowledge dissemination and upgrading the skills required for the industry is one of our main objectives of the association, and we have been doing a lot of activities, especially during this lockdown period. A lot of webinars have been organized from some of the best experts in the country and also some outside, and on various topics which are relevant. And also we have organized many panel discussions how to handle this COVID-19 impact on the construction industry. I'm sure all our members would have got some value out of all these programs. And I should compliment all the centers across the country also for taking up the issues very seriously and doing activities in their regional centers. So, as President of Association of Consulting Civil Engineers, I am very happy that all our members, 5,000 plus members, are very active, and they are in touch with their regional centers and coordinating various activities during this lockdown period, and helping each other and also helping the society in general wherever there is a requirement and support required. Our members are responding to it. In fact, during the initial period of COVID-19 lockdown, many of our members went out and supported the community, construction community, and also the general public wherever the help is required. And our members have also contributed to the Prime Minister's Care Fund and Chief Minister's Relief Funds also. So our members and in general ACCE is very responsive to the society's requirement, and we are very sensitive to the society. And this sustainable engineering series is also a part of the sensitivity of the association, which responds to the need of the hour. And when the whole world is talking about sustainability, and ACC has also taken it up very seriously, and a separate working group has been formed under Dr. Ajit Sabnis. In the days to come, we'll be working with all the competent authorities, and also we are also planning closely working with the Bureau of Indian Standards and other green building initiatives and the smart cities initiatives to bringing sustainability in the construction industry. So this is a small effort from our side, a series of lectures, and after this, the outcome of these series of lectures and also the feedback from all the participants will be taken up very seriously and implemented wherever it has to be. And I am very happy, and I wish the program leader, Dr. Ajit Sabnis, the program moderator, and also the Bangalore Center Chairman Srikanth and Secretary Srikanth and Chairman Rajesh Kangan all the best for the program. And I wish all the participants will be interactive during the program of series of lectures, and they'll attend all these lectures so that they'll also get a certificate at the end of the program, and also they can implement whatever they're learning in their day-to-day practices. So thank you, Rangnath and Ajit, for giving me the opportunity to explain what ACC is doing, and we are very serious, and we are concerned, and we are responsive to the society, and wherever there is a need, definitely ACCI will be there pitching in our own efforts to make our society a better place to live in. Thank you very much.
Thank you. Thank you very much, Mr. President. Friends, we now start today's presentation on why sustainability is the need of the hour, the basic terminologies and definitions by Dr. Ajit Sabnis. I request Engineer Savina Kumara HC, Treasurer of Bengaluru Center of ACCI, to kindly introduce today's speaker, Dr. Ajit Sabnis.
Thank you, sir. Good evening, everyone. It's my privilege to introduce today's speaker and the program leader for Sustainable Engineering Series, Dr. Ajit Sabnis. Dr. Ajit Sabnis is a graduate from BMS College of Engineering, postgraduate from INA and Company University. He has a total experience of 40 years in the field of engineering. He has his credit more than 350 completed projects in India and abroad. During tsunami days, he offered his services as a consultant to Red Cross at Maldives. He is also the project director for the 3 sustainable projects under UNEP in India. His specialization provides sustainability assessment of buildings and infrastructure projects prior to actual construction phase, enabling concerned stakeholders to evolve and adopt right kind of methodology, technology, and global warming mitigation strategy, moving towards sustainable development. His passion is to disseminate the right kind of field knowledge among the civil engineering fraternity made him to initiate publishing a reference magazine called Build Expressions, which won the Best Indian Construction Industry magazine title in 2012. He has published several articles and papers in various magazines and international journals. We welcome you, sir.
Yeah, thank you, Savina. Ranganath, you are muted.
Yeah. Dr. Ajit Sabnis, the floor is all yours.
Okay. Yeah, can you see the screen?
Not yet?
You're not seeing the screen?
Yes.
Yeah, we can see, but the poster is there.
Yeah, your screen has not come, Ajit.
Huh?
We can't see your presentation.
The brochure is there.
Brochure is there. Slide has not come.
Okay, 1 second.
I'll pull down the brochure.
Yeah, this brochure cannot be taken out?
No, that actually goes into the background. The moment your screen comes.
Can you see the screen now?
No.
Now?
Yeah. Now it's coming on.
Slideshow, you can go. Yeah, I can see now.
Okay.
Yeah, perfect.
Perfect?
Yeah.
All right. So, good evening, all participants. And before I actually begin, let me thank Savina for that wonderful introduction, and then moderator Ranganath, President Ashwath for giving the opportunity to use this platform and then take forward the sustainability aspect of it. So I think everybody has spoken quite a lot about various aspects of it, but let me focus 1 or 2 slides what exactly is this sustainable engineering series all about is. ACCI Institute, as already mentioned, we have actually 4 verticals. Can you see the screen or change your screen?
The first slide is still there. The second one has not come on. Yeah.
Can you see the slide now?
Yeah.
Okay. Friends, sorry for that glitch. So we have, these are the under 4 ACCI institutes. These are the four verticals under number one is the sustainable engineering, about which we are talking about it now. The second vertical is structural engineering aspect of it. Third one is the construction engineering. Fourth one is material engineering. Now, as far as today, what we have taken up is the first vertical under sustainable engineering. We have, as already mentioned by Kannan, we have a series of talks, about 9 talks in this series, which will actually give starting from an overview about sustainable engineering till almost the sustainability assessment, its measure, its objectivity, its mitigation. All these things will be covered hopefully by the experts in the next 10 weeks. So all these verticals, participants, for your benefit, all the presentations will be made available on the slide share. That is point number 1. Details about the explanation of each slide and all those things will also be available on the ACC website. There will be a detailed explanation on the blog about which all the links will be furnished to you all. Probably when you attend the next talk, the previous talks details and links will be provided to you people. And for all those students who participate at least in about 7 out of 10 sessions, each will be given certification. And then please note that you have to be registered for minimum 10 aspects of it. And all these will be also published by one of the special publications under sustainable engineering, and that is what Ranganath informed me. Dear friends, before we actually begin, it's estimated by International Finance Corporation that the market potential for green buildings to be around $25 trillion by 2030. So it is for your future, and you got to try to gain as much as knowledge as possible as far as the sustainable engineering is concerned. And then this is in this effort, in this direction, ACC actually is trying to give you a lot of intimation and then information. Now, I have a third slide which is coming up. Ranganath, I think I'm not, yeah. Okay, this is the third slide. In this session, in the next 45 minutes or so, I would like to cover these 13 to 14 aspects of it. This introduction is not going to be technical. Most of the definitions, most of the explanation, what you are going to hear in the next 30-40 minutes are probably known to you people. And for those who are not aware of it, it is better to try to understand these things, because these definitions, these terminologies lay a pathway to the next talks in the coming series, in the session. So let us go about it. We don't have to read all the things, but these are about 12 to 13 definitions which actually are going to place it before you. Now let us go to the next, the first definition. Let me begin with the story of the sustainability itself. The story of the sustainability is not very new, or it has not come into the picture only in this decade. What is actually this? Sometimes in 1950s, where the present probably the developed nations were in the stage of developing nations or the developing economies. Sometimes in 1950s, what is called the Club of Rome was formed with a few engineers, architects, and then a few scientists came together, and then they formed what is called as Club of Rome. Subsequently, they started discussing how to reduce the reduce the utilization of the natural resources. All these things, they started talking about it. Then the word sustainability, the sustainable society actually came into the picture. Now it all began, so the first summit was in 1992, Rio, Brazil, where the convention included adoption of United Nations framework on climate change. Hello? Am I audible?
Yes, please go ahead.
Yes,
Okay.
please go ahead.
Yeah. In this first summit, the Rio, Brazil, 1970, the UN framework on climate change was adopted. Climate change, the terminology actually came sometimes in 1940s, and then the terminology global warming approximately came in 1975. So this is the first summit in 1992. In this conventional framework, it was mainly thought the focus was on stabilizing atmospheric concentration of greenhouse gases, and this was subsequently followed by what is called as the Kyoto Protocol in Japan in 1997. Now, this particular summit placed heavier burden on the developed nations, being responsible for the current high levels. The current high level was at that point in time of greenhouse gas emissions in the atmosphere as a result of more than 150 years of industrial activity. The next summit was actually in Paris summit, which actually was in 2015, and about 195 member economies participated in this under the United Nations, and then developed nations pledged financial assistance to the extent of $100 billion US, which subsequently the Trump's administration actually took this back, and then this contribution of $100 billion US for the purpose of promoting sustainability throughout the world and is not available to us. But all the other countries have come together, especially all the developed countries, including India as one of the developing countries, including China, India, and all those things. They have come forward, and then they take forward this the very concept of developing sustainable society. Now, these are the two things. And one more important aspect of this summit was actually India played a major role in formulating all the sustainability development goals. And it was in this Paris summit, the question of the idea of sustainability development goals came into the picture. Earlier to sustainability development goals, there were what were called as MNDs, or the Millennium National Development Goals. So this was replaced by Sustainability Development Goals, and then all the 195 countries were actually bound by INDCs, what are called as intended nationally determined contributions. So this was the highlight of the four important forums which come into the picture. Now, let us begin with a few definitions, and then all the subsequent slides are in the form of question and answers, and let us begin understanding what exactly is sustainability. What is sustainability? Sustainability, as far as the World Commission is concerned, as far as the United Nations Environmental Program, United Nations Development Program, UNDP, UNEP, etc., they mainly define sustainability in terms of sustainable development. And sustainable development is that which meets the current generations without compromising the ability of the future generation to meet their own needs. So this is the World Commission. This is the definition which the World Commission of the United Nations brings into the picture. As far as our National Building Code 2016, Part 11, Approach to Sustainability, which has been very elaborately dealt in NBC 2016, defines sustainability as the state in which components of ecosystem and their functions are maintained for the present and future generations. So these are the two very important, essentially the same thing, but these are the two very important definitions of sustainability, where most of the things, most of the organizations, everywhere these definitions are actually adopted. And sustainability also takes into the 3R principles, reduce, reuse, and recycle principles into picture. Now, next, when we come to what exactly is sustainable development, we understood what is sustainability and what is sustainable development. sustainable development has to be firmly founded upon three fundamental pillars of economy, socio-cultural, economic, and environmental aspects of our society. How can the world economy and population continue to grow forever when the earth resources are finite? Economic growth has to reconcile with the environmental stability. True sustainability stands very firmly on these three pillars of economy, socio-cultural, and environmental pillars. This also brings in the element of what is the difference between sustainable development and then green development, sustainable construction and green construction. It is very often, very commonly used or interchanged. Sustainable construction is interchanged with green construction. Sustainable development is exchanged with green development. Though at macro level these are same, but there are certain subtle differences between a sustainable building and green building. That we will talk about it as we go further. Now, when we understand what exactly sustainable development is, now let us come to what exactly are sustainability development goals. Sustainability development goals, which are actually very commonly acronymed as SDGs, and these SDGs are actually global goals that were adopted during the Paris Summit, as I told you, that was COP, Conference of Parties 21, and as a universal call to act upon so that we can end poverty, protect the planet, and ensure that all people enjoy peace and prosperity by 2030. Please note that this 2030 was the commitment made by 195 member economies under the United Nations Charter, and they gave about 50 years, which is extremely less for any kind of implementation of sustainability development goals. However, these 17 sustainability goals actually summarize all the global challenges that whether it is a developed nation or it is a developing nation or it is the developed economy, all the challenges faced by the countries are actually categorized and brought into these 17 challenges, and these are actually called as 17 very important sustainability development goals. Under these 17 sustainable development goals, they are further classified into about 169 targets and goals. There are sub-goals, and then there are what are called as voluntary disclosures by every nation. Each nation represented by its head of the state should voluntarily disclose as to what kind of actions they have taken, in what way it is implemented. All these disclosures have to be voluntarily made by each member economy to the global community. So these are the 17 sustainability development goals, what you see on the screen, starting from poverty. All these details, you get it. So let me not spend too much of time on these, explaining all the 17 development goals. But as far as the civil engineers are concerned, as far as the civil engineering profession is concerned, we are actually directly connected with about 6 sustainability development goals. And these sustainability development goals are Sustainability Development SDG 4, which talks about quality education. And please believe me that the new education policy for higher education gives a lot of importance and then impetus to this quality education program, SDG 4. And I forgot to mention you, when we talk about 2030 in the earlier slide, all these 195 member economies under United Nations Charter are actually supposed to make their development or make their research, everything focused on these 17 development SDG goals of the sustainability development goals. So SDG 6 is concerned with water and sanitation, SDG 9 connected with industry, innovation, infrastructure development, then sustainable cities and communities, and under this category came the smart cities, which never took off, and then climate action came into the picture, where civil engineers as nation builders play a very, very critical role, and then partnerships for the goals. And out of 17 different goals, we as civil engineers, and then probably every agency, every organization in achieving the sustainability development goals has to partner with somebody or the other, and that is where the things come into the picture. So the entire construction industry professionals, especially civil engineering professionals, are directly connected with these 6 goals and indirectly connected with several other goals. Now, after understanding what exactly sustainability development goals are, we will see what is sustainable construction. Sustainable construction has not been very satisfactorily defined so far because there is no one specific definition for sustainable construction. There are several. Few of them I would like to mention here. 2 of them I have picked up. Sustainable construction is the creation and responsible management of healthy built-in environment based on the resource-efficient ecological principles. And the second important definition is a holistic process aiming to restore and maintain harmony between the natural and built environments and create settlements that affirm human dignity and encourage economic equity. This is what the sustainable construction actually meant. And when we define, look at these, any of the definitions here, it actually encompasses the 3 important pillars what we saw. And of socio-cultural, economic, and environmental pillars of the sustainability. And the sustainable construction encompasses not only the definition, what is implied here, but also takes into cognizance the impact and the effect on all the 3 spheres of socio-economical, environmental, and the cultural, the economic aspect of it, all the 3 aspects. So this is what the sustainable construction is. When we talk about green construction essentially deals with, in its specific approach, it mainly concerns with the environmental pillar of the sustainable development. So sustainable construction encompasses green construction, and then green construction focuses more on the environmental aspects of it, whereas the other 2, socio-cultural and the economic aspect of it, are not given much importance or much emphasis as far as the green construction aspect is concerned. So this is one of the subtle differences between sustainable construction and green construction. Now we will look at what exactly are few of the definitions which are very important. Now, what is built environment? We all know what exactly built environment is. Everything that is built for the human comfort, and then all that space in which people live, work, commute, recreate on a day-to-day basis. And everything that, whatever we construct for the human comfort comes under built environment. So this all we know about this. Now, what are the responsive, what exactly is responsive built environment, and then civil engineers view. Now, civil engineers are actually responsible, or the built environment actually is responsible for the greenhouse gas emissions and contributes to global warming, indiscriminate use of natural materials in construction resulting in resource depletion. Entire construction process is extremely energy intensive, resulting in the carbon spike phenomena. What exactly is carbon spike phenomena? We will look at it little later. And then these responsive buildings actually interact with various ways throughout their life cycle. They consume resources in the form of energy, water, materials, etc., and emit huge amount of greenhouse gases and then waste. We civil engineers endeavor to minimize a building resource consumption, waste generation, and overall ecological impact to within certain nationally acceptable limits. Now, once we understand what are the, let us look at what exactly is the extent of contribution of the construction industry, construction sector. Now, globally, buildings are responsible for about 40% of the energy use and an estimated 42% of the global water consumption, and 50% of the global raw materials consumption is by buildings, an estimated 50% of the world's air pollution, and 42% of its greenhouse gases, 50% of all water pollution, 48% of solid waste, all the chlorofluorocarbons are due to built environment. Now, once we understand what is the extent of the contribution by the construction sector, let us look at the global overview of what exactly is the global carbon footprint by the construction industry. Let us take only top 3 countries into the consideration. For example, China has got the highest GHG emission. USA comes next. India is. So look at the differences in figures. 10.10 gigatons against 2.65 gigatons. Similarly, we have global footprint of buildings, raw material consumption, energy use. These figures, the table gives actually clear and quite self-explanatory. You know, it is often, the students often ask me how much we presume, we understand carbon dioxide as a gas. Then when it is converted into kgs or into weight basis or into mass basis, how is it possible to visualize? So this is, for example, I mean, there is what is called as carbon cube, you know, carbon dioxide cube. So it is approximately 27 feet by 27 feet by 27 feet is a cube is known as the carbon dioxide cube. And approximately 1 ton of carbon dioxide gives you about 0.56 cubic meters. An average citizen in urban scenario produces about 8 tons of carbon dioxide per year, whereas US citizen produces about 17 tons. The Indian average is about 2 tons per year. So this is the general scenario, and let us now go to the next slide and try to understand what exactly is the greenhouse gas effect. What is greenhouse gas effect and what is global warming? Now, greenhouse gas is a gaseous compound in the atmosphere that is capable of absorbing infrared radiation, thereby trapping and holding the heat in the atmosphere. Accumulation of greenhouse gases leads to greenhouse gas effect, and this subsequently leads to the global warming. Now, what happens is sun, extreme intensive solar radiation across the entire electromagnetic spectrum, including the infrared and then ultraviolet fields. It actually reaches, radiates, and then majority of it, almost about 75% of the this intensive solar radiation actually gets reflected back into the space. Why? Because there is water. This reflection or the reflection happens because of the Earth's surface, because of the water surface, and then because of the polar, the ice caps, the Greenland ices, ice sheets, etc. And then actually 25 to 30% gets actually absorbed by the Earth's surface, and many of the earth water, the ocean water, everything gets absorbed. Now what happens is this actually, then some of the things, and during the presence of these gases, there are a lot of gases, the greenhouse gases, which are already present in the atmosphere, and which actually are very helpful if they are in a within the permissible limits. They don't also allow the ozone, the ultraviolet rays to adversely affect the habitat on the Earth, on the planet Earth, on the Earth's surface, and also when these greenhouse gases also have tendency to trap the heat that is reflected back by the radiation reflected back by the Earth's surface. And thus what happens is there is a formation of the blanket of greenhouse gases which start trapping the Earth, the radiation that happens from the Earth's surface. And this creates huge warmth in the atmosphere because of the heat is not able to escape into the atmosphere, resulting in what is known as global warming. We will understand what is the impact of this global warming and then what exactly are the different greenhouse gases. There are several greenhouse gases, but some of the important greenhouse gases are actually carbon dioxide. When we call it as carbon footprint, it actually is the carbon dioxide footprint. So carbon dioxide is one of the important gases. Methane is another very important gases. Methane, then nitrous oxide, then we have hydrofluorocarbons, then other fluorocarbons, then we also have sulfur hexafluoride, etc. These are the important greenhouse gases which actually come into the picture. Now, how do we understand these gases? How do we measure these gases? What exactly is the unit of these gases? These gases are understood or explained by what is called as the global warming potential. What is global warming potential? It actually is the relative measure as how much heat greenhouse gas traps in the atmosphere. All these gases, what we talked about, what you see on the screen, have got what is called, they actually trap heat, and the intensity of the heat they trap is directly proportional to the number of years, and also the intensity, because the intensity varies, it is extremely important to form a benchmark. Because the carbon dioxide and all these gases, greenhouse gases, have not only so they are dependent on the intensity of the trapping of the heat varies, and the number of years or the period or the life cycle of each gas in the atmosphere, that varies, and then the mass of each gas varies. All these things, so it becomes extremely important to have one base figure or one benchmark, and hence this global warming potential came into the picture, and carbon dioxide is taken as the benchmark, because carbon dioxide doesn't dissolve in the atmosphere very fast. It takes few centuries to completely dissolve the carbon dioxide that is accumulated in the atmosphere. So even if we stop emitting carbon dioxide today, we will have, it is estimated that the effect of carbon dioxide will be there at least for about 40 to 60 years. So dear friends, as engineers, when we take the design life of a building or design the building is with a lifespan of about 60 years or 70 years, and then if we don't take this existing effect of greenhouse gases right now into our design, we will be doing injustice, and that is why the need of the hour, and that is why the sustainable design or the contemporary ecological designs, all those things come into the picture. Now coming back to this global warming potential, the carbon dioxide is treated as one and is taken as one for a specific mass. So all other gases are converted. For example, I'll just only explain the methane part of it. Methane has got, when you compare methane, actually it is extremely more detrimental than carbon dioxide. But methane stays in the atmosphere only for about 12 years. And then when you take the historical long period, that this 12 years actually become extremely negligible. So when you compare it with the same mass of carbon dioxide, for a period of about 100 years, methane has got the global warming potential of 25. That means it is methane over a period of 100 years, it is 25 times deadlier than the carbon dioxide. Because it gets dissolved in about 12 years, it doesn't take into consideration the carbon dioxide is the reduction in the greenhouse gases, and the importance for the greenhouse gases, the carbon dioxide mitigation comes into the picture. So this is, and also in the figure, what we actually see in on the P chart, the carbon dioxide, which comes to you about 65%, etc. All the other greenhouse gases will come into the picture. So next we will go to what exactly is carbon dioxide concentration. And carbon dioxide concentration is actually the measurement of carbon dioxide in terms of ppm, parts per million. Now in 1750, when the James Watt first put the steam engine or the industrial revolution started, carbon dioxide concentration was 280 ppm. Now, right now, it is estimated that we are in the range of about 415 plus parts per million, and by 2100, it is estimated to touch about 800 ppm. It is also said from health point of view, when the CO2 concentration comes near to 500, it is extremely difficult, and then it plays havoc on the human health. And at that time, at the same 1750, when the Industrial Revolution started, the global population was 800 million, and now it is about 7,150 million, and 2050, exactly 200 years later, we will have a global population of 9,000 million, which is directly proportional to all the development and the chaos that is going to happen. So this is where the importance of sustainability actually come into the picture. Now, what exactly are the feedback amplifiers? These are some of the very important definitions which come into the picture. Probably we will, is important. Now, feedback amplifiers, let me explain with two examples. The polar amplification. For example, these feedback amplifiers are those incidents or those events which actually amplify the global warming. For example, because of the extensive heat of the global warming, the melting of ice takes place. Melting of ice actually exposes the rock portions. When the rock absorbs more heat, and then surrounding becomes more warmer, and this further increase in warmth will further deteriorate and then melt the ice, and then responsible for the ocean levels increase in the ocean, etc. So this is what the amplification, it amplifies. One incident actually gives rise to another incident and keeps on amplifying. The other important example we can come with excess of humidity. What exactly is humidity? Humidity is nothing but the concentration of water vapor in the atmosphere. When this concentrated vapor in the atmosphere increases, and water vapor is considered as one of the gaseous forms of water, and this gaseous form of water, the vapor has got tremendous heat trapping capacity, and then it keeps in more and more, traps more and more heat, and then gives rise to lot of humidity, and then it further amplifies the global warming. So these are such events are actually called as feedback amplifiers. And the next important thing, what we are definitions, what we see, what exactly are the planetary boundaries, what are the effects of global warming, what actually are the tipping points. The graph, what you see on your screen is actually the planetary boundary graph, which tells us that which are the eco indicators, that is the 11 eco indicators. What you actually see are the important 11 indicators considered by the United Nations. And for example, climate change and then biodiversity. The red circle, concentric circles, what you red zone is actually the dangerous zone. And the climate change, when it comes for we have already in the brink of danger zone, and then beyond that, climate is going to change. So these are the planetary boundaries. We have biodiversity loss. We have already crossed the limit, and then this crossing of the limit is actually called the tipping point in the environmental parlance. So biodiversity, we have already lost several thousands of species because of the global warming. Now, what actually are the effects of global warming? These are the few pictures what I have stored it for you. And the global warming, ocean acidification. Ocean acidification, that means the global warming has caused heating of water even in the to the depth of about 700 meters below the surface of ocean. So there the warming is felt, which has never happened in the last 8 lakh years or so. The ocean, the higher amount of intensity of carbon dioxide leads to generate carbonic acid, which ocean acidifies the ocean, which is detrimental to the entire ecosystem. And then there is an effect of eutrophication, forest fires, deforestation fires, habitat fragmentation, soil erosion, and water depletion. These are some of the adverse effects of global warming. Next, let us come to what exactly is urban cycle. What is urban cycle? This I would not like to spend much time. We know that there is a lot of rural migration that is happening. Migration leads to urbanization, leads to industrialization, then it leads to infrastructure development, environmental impact. That leads to greenhouse gas emissions, then global warming, then the man-made disasters, and again the cycle keeps on repeating. See, there are one set of people as a part of this migration who do not migrate from one place to the other place looking for a better life or better lifestyle or better education or to earn more. But there is a part of the migrant population which only shifts or migrates only from safety point of view. These actually, they may shift from flood areas, flood terrain to the higher up mountain areas. These actually people, the population is called the environmental refugees. Then we all know about what urban heat island is and global warming in a specific gated community. And this is more so in the urban scenario. We have more reflecting surfaces, so let us not spend much time on this. Now, when we have understood all this, why sustainability comes into the picture? We have seen unprecedented events in the last few years. These unprecedented events have actually, even right now in the last 9 months or 10 months, not only the pandemic, but parallelly because of the climate change, we have seen huge amount of floods, rainwater, unprecedented rainfall, change in patterns, rapidity with which the greenhouse gas emission is increasing, melting of glaciers, floods, and other anthropogenic calamities. All these things actually cause huge amount of change in the climate, change in the patterns, everything. Now, we also talked about 2030 agenda. The whole globe, the international community is referring to what is known as 2030 agenda. This 2030 agenda is nothing but what we discussed in our one of the previous slides where Paris summit, all those things. And what exactly is 2030 agenda? We talked about global warming, and global warming actually increases the average Earth temperature. Now, average global, Earth temperature, when it increases, it causes huge amount of impact, what we saw in the last slide. So the need of the hour, or the agenda 20, what they call, is actually to contain the global warming or the increase in temperature to the extent of about 2 degrees centigrade or something like that. See, the average global temperature of 1 degree approximately causes 1 meter of sea level rise, increase in the ocean level that increases. Now, coming back to national, carbon footprint as well as the global carbon footprint, India produces total emission of responsible for about 7% of greenhouse gases emission, and construction industry is responsible for about 40% of the total emission. So this is not very important. This is known to everybody. And let me come back to the very important aspect of what National Building Code talks about. National Building Code also talks about elements of sustainable construction design parameters. This is the title actually, elements of sustainable construction design parameters. It talks about 10 important elements of parameters: inclusive approach and the use of technological advances. You know, the whole things have to be taken into consideration. It is not, sustainable development is not going back to cave period. No, nobody has said that, but it has to embrace the advancements that is happening in the technologies, the new generation materials that come into the picture, the new software that is available, the new platforms that are available, and not only that, we need also our cities and then our entire design should be adaptable to the climatic zones, and these climatic zones, the climatic conditions also keep on varying. So when we synergize and then bring harmony into all these elements, actually when we come to the construction aspect of it, we actually land up in categorizing all these 10 important parameters of elements of sustainable design into these 6 important, let us say, construction industry parameters. And all these things can be classified as space for and structural design. Second part is that we need to look into the conventional and alternative materials, sustainability assessment, construction technology, building automation, construction mechanization, and artificial intelligence. All these aspects have to be taken into consideration. Now we come to what are known as, when we start taking the elements of parameters into consideration, and also we take the advancements that we saw it in the previous slide, then we understand that the linear construction where take, make, use, and dispose doesn't hold good. It's not valuable. It's not possible now, and yeah, sorry for that. So the linear construction does not hold good. Now there are 2 important terminologies which have come into the picture. There is what is called, similar to circular economy, there is what is called circular construction. Circular construction essentially goes with the understanding of cradle to cradle principle, where the products and assets are designed to be more durable and to be repaired, refurbished, and reused, and then disassembled. Now there is also a concept called, the new concept, what is called as BAM, the buildings as material banks. This principle of design construction takes actually contemporary ecological design into consideration, and every building has to be designed as a bank for the material banks. So, for example, I was listening, for example, the new Tata Nexon vehicle, the new electric version of it is, I understand that is one of the first vehicles where every part of it is designed in a way that every part of it can be reused, and then or it can be recycled or sold back to the garage. That is why we need to be very extremely proud of this. So this is actually the 3 important circular construction and BAM are the 2 principles which are actually gaining a lot of importance. The next. Sorry, I think it's okay. Yeah. Now let us understand what exactly. There are only about 3-4 slides which I have. Please bear with me. I've crossed a certain time, and this is a very, very important phenomena. What is called the carbon spike phenomena. What exactly is this? Now I also touch upon the entire building's life cycle. We have 4 phases. We have pre-construction phase, which actually is the represented PCP. Then we have construction phase. Then we have operating and maintenance phase. Then we have demolition phase. We all know that operating and maintenance phase has spread over about 75 to 80%. Takes about 75 to 80% of the span of through the entire life cycle period, and then the pre-construction period and construction period and the demolition period actually are very extremely short duration. Whereas if you consider the same life cycle period from the greenhouse gas emission or from the highly intensive energy point of view, construction phase, which actually consumes huge amount of energy intensive. Because it is actually, this consumes extremely high energy during a very short period, say about 3 to 4 years, or even 2 to 3 years or 2 to 4 years, as compared to 70 to 80, let us say 70 to 80% of the design life of the period. So the most of the energy to be spent, though it is extremely high in the operative and maintenance phase, it is equally distributed, and more or less it is streamlined for the simple reason that we have gadgets, we have appliances, more or less actually streamlined, or they have become more and more energy efficient. So the actual problem comes into the construction phase, where extremely high intensity of carbon dioxide or the greenhouse gases are emitted, and in a very short duration. And very unfortunately, this actually is the phase completely neglected by all sustainability assessment organizations or the parameters. So this is where, as engineers, as civil engineers, actually need to this is need of the hour, and then we need to reduce our carbon footprints, etc. So this is after having understood what exactly is the carbon footprint. Now, what exactly is the eco-design, and what exactly is the comprehensive ecological design part of it. So let us look at it. I mean, it's eco-design is a form of design which minimizes environmentally destructive impacts by integrating itself with the living processes. This is given by Ryan and Stuart, one of the important things. But when this definition gets integrated with the advancements, with the conventional eco design gets integrated with that of the emerging trends in construction, and we call it as contemporary ecological design. Then eco-design actually calls for significant amount of knowledge and experience about the sustainability issues. And it is very unfortunate that many people claim that we use less embodied energy material and our buildings are sustainable. Dear friends, it is just a myth. It is not true. It's unless we understand the whole lot of knowledge, experience in understanding what exactly is the issues, impact, and we come across, we will not be able to produce or provide contemporary ecological design. One of few of the important parameters which we need to consider during the ecological design is energy trade-offs, and then wind direction, its sun path. That is essentially the passive architecture part of it. Building orientation, passive heating, passive cooling, passive lighting, ventilation. All these things to be integrated with all the 10 elements what we talked about, the other structural part of the designing, etc. And we now come to the one of the last important aspect of the eco-design. What actually the eco-design parameters include. It's actually the previous slide is an extension of this slide, which should have been reversed, but it essentially comprises of passive solar designs. Then we need to understand how the daylighting takes into picture, envelopes, what kind of renewable energy that goes into the picture, and then what is the kind of different materials, eco-friendly materials, what different specifications, then MEP services, indoor air quality, acoustics, all these things. Eco-design should also be anticipatory, responsive, and resilient. In the last 2 months, we all know what kind of level of resilience our urban designs have been. We don't have infrastructure to cope up for one small pandemic. We don't have the cities or the towns don't bounce back because they are not resilient enough. And we cannot face these things comfortably. That is for the very simple reason that our cities are not responsive to all the entire. But eco-design has to take entire thing into consideration. Now, with this, I think I have covered most of the important terminologies and definitions that may come up in the next few 9 to 10 sessions. and I'm extremely sorry I have taken little more time than what was allotted to me, and hope the session was clear. I was audible, and thank you very much. Over to you, Ranganath.
Thank you very much, Dr. Ajit Sabnis. That was a very good eye-opener, I would say, for all of us on the subject of sustainable engineering. And I'm sure many of the members present here, they would have appreciated some of the basic points that you touched upon, and also related civil engineering designing to the environmental impacts and what are the parameters that need to be considered in designing aspects and all. Thank you very much for that. Friends, if there are any questions that you need to ask, you can please post them in the chat box on the site. We'll take a 5-minute breather for you to put up all those points in there. During which time probably we'll just inform you about certain other aspects that are going on in the association. Like someone was inquiring whether this particular presentation is going to be made available, as was suggested in this one. It will be put up on the our association's web. You can all access it. And also, one more aspect is we have, like the Institute's working group, we have another working group called ASP-SDI Publications Working Group, wherein we are trying to publish a lot of information on civil engineering and other related matters. And also, we bring out newsletters on monthly basis. We also have bulletins, which we are going to bring out twice in a year. That's still in the making. And all these information that is being discussed here, we intend to bring out a booklet for all the 9 and the panel session as well on the last day. And it's going to be published by the association, and it will be made available to all those who are interested. If anybody has any question, if they want to raise it here, please put up, and we can start taking the questions. Has anything been put on the chat box? Anyone want to raise any of the points?
Yes, Dr. Ranganath, I have put my query in the chat box, please.
You have put your query.
Shall I read it out?
Yeah, you can.
Yes, thank you for this opportunity. Dr. Ajit, I think almost 99.9% of civil engineering professionals would 100% want to support the sustainability movement. But the biggest challenge we face are twofold. One is, how do we do it? That is the knowledge bank. And the second one is availability of suitable cradle-to-cradle material, recycled material in the market, which are cost effective and available to the scale that we require. So these are the two challenges. So what are the views about this? How do you go about doing this? Thank you.
Girish, thank you very much for this. I request you to have patience for the next 9 sessions.
Okay, thank you.
In the beginning, we have said that all these issues will be discussed, and these things cannot be just discussed in just a 45-minute session. I request everybody to wait for this thing. Probably once this platform of awareness is created, if it is required, probably a next session of series for a higher advanced level, we can actually escalate the entire knowledge dissemination to the next level. So I request all those participants who have a similar question or like what Dr. Girish asked, I request them to have patience for we have very eminent speakers who are coming on talk on materials, how do we implement these things. I request participants to kindly mute their audio so that it doesn't disturb the others. Yeah, thank you. Thank you, Girish.
Thank you, sir.
Yeah, I request participants to kindly shoot because there are so many chats. It's extremely difficult to find out which is the question. So I request people to kindly shoot the questions so that I can directly take those questions. Is that okay?
Good evening, sir.
Yes, yes.
So good evening, sir. May I speak?
Yeah, please try. Please tell your name.
My name is Kartika, and I work as an assistant professor in CBIT at Hyderabad. So I wanted to know as to how we can associate with ACCI in order to improve all these, aspects in an educational institution in collaboration.
Yeah, it's a wonderful. May I request all the participants to mute their audio, please? See, ACC welcomes this, and there is a possibility that there is an organizational member and possibility in ACC. So there are many organizations, many institutes, many colleges, many deemed to be universities are organizational members of ACCI. So one way of becoming aware and then getting associated with this wonderful organization is become a organization member of ACCI. And once you are doing that, automatically then there are possibilities of your college getting, students getting the possibility of getting inducted into the students chapter. And of course, there are very minimal, each student chapter will be supported by ACC. Then we have similar lot of benefits by becoming an organizational member of ACC. So to get associated with such kind of programs and events and such platforms and then ACC Institute, I request your organization please make effort so that you become an organizational member of ACC. Am I clear?
Yes, sir.
Thank you.
Yes, sir. Thank you so much.
And you can contact ACC office for getting all the details of the membership.
Yes, sir. Thank you so much. Because we do have subjects related to sustainability and green building technologies, and it ends there. So we want to go a step further so that we can inculcate this as a practice so that the outcoming engineers will be able to implement something like this.
Yeah, please become an organization member of ACC so that you have lots of experts, not only people who are talking on these 9 days, but we have lot of experts who have got lot of exposure and very senior consultants who are already well versed with many other things. We will be very happy to guide your students and then guide some of the faculty, ma'am.
Thank you so much, sir. Thank you. It was a lovely presentation, sir. Thank you.
Thank you. Yeah, any more questions?
Sir, may I speak?
Sir. Yes.
Sir, I am audible?
Yeah, please.
Yeah, you are.
I am Ravinder Shekhar from Jammu.
Okay.
Member of CCE. Sir, basically there is still a lot of people or engineers who have to understand between a sustainable construction and a viable construction or a real construction. People think that they build a house, they are building such a building that is fully occupied, people are living in that, so that is a sustainable. But in real sense, it is not a sustainable as far as my knowledge is concerned. Sustainable means that we are constructing without compromising for our future generation.
True. Yeah, what is the doubt?
This is a sustainable. That is my.
Oh, sir, it is not a sustainable construction. I think if you have joined the session little later, I don't know. But we have been actually right through the entire 45-minute session was sustainable. What exactly is sustainable construction? What is green construction? All these things were explained. Sir, I would request you to kindly go back. These slides will be made available. The presentation will be made available. It will also be made available on the slide share, and it will be available to the public. You can go through that. Any specific doubts, you can mail it to the ACC, or you can go to the mail at the end. You can even mail me. At the end, I will put in the last slide of mine, I had mentioned my email ID. If you have noted it, you can mail me. We'll be very happy to answer you if you have any queries on sustainable construction aspects of it.
Definitely, Doctor.
Yeah, thank you.
Good evening.
Sir.
Yeah.
This is Shriru Gupta from Indore.
Yeah.
Sir, my question is, what is MEP services?
The mechanical, electrical, and plumbing services in addition to all HVAC, etc. Did I make it clear, sir?
This.
Hello?
Yeah, I think he's muted himself.
Yeah. Yeah, we can go to the next question. Yeah.
Hello.
Yeah.
Sir, very good evening. I'm Omkar Bhosle from Mumbai. I'm a student of RIC Samity.
Yes.
Sir, as you mentioned that carbon, methane and other gases take centuries to withdraw. But during this lockdown period, as there were no industries and vehicular traffic, so there was a very evident reduction in the pollution. So why was that so, sir?
Sir, that is because, see, the greenhouse, primarily the greenhouse gas emission now contributes to almost about 20 to 25% because of the human efforts. So during the pandemic period, there were no activities, no industries working, there were no vehicles on the roads. So in a sense, the burning of the fossil fuel was minimized, not as compared. So what we saw was only the clean air. So there was definitely a reduction in pumping of the greenhouse gases or the greenhouse gases to the extent of about 3 to 4 months. Now it has all come back. The carbon dioxide concentration, CO2 concentration reduced considerably. We saw very clear Delhi from the satellite images showed a very clear Delhi, all those things. But dear sir, we have come back to the original now. There is no reduction in CO2. We have come back to 400 plus ppm, and we have foggy cities have already started. And this, when you compare the long historical period of 100 years from where the locked in, we call it as locking period of greenhouse gases. The locking period of greenhouse gases in the atmosphere is from 40 years to 100 years. So when we take the impact of this 3 to 4 months on 100 years, this is actually a negligible thing. So only because the fossil fuel, the burning of the fuel, the burning of the diesel, petrol, everything, no industries gave pollution into the atmosphere, we had slightly a clear air to breathe. It nowhere reduces the effect of greenhouse gases, or the global warming was not reduced at all. In the same pandemic period, we are seeing extremely different pattern, seasonal changes, rain patterns. I don't remember the rains in the month of September so intensified in the last few years. This itself shows there is a complete change in the rainfall pattern. So greenhouse gas effect has not deteriorated at all, and 3 months or 4 months is a negligible period. When we talk about future generation, we need to cater for at least working for this, towards this, at least for the next 40 to 50 years beyond our generation too.
Okay, sir. Thank you.
Yeah.
Sir.
Yes, sir.
How MEP services are related to sustainable development?
I didn't get you, sir. What is it?
How MEP services are related to sustainable development?
Sir, for example...
Can you repeat? Did you hear, Ajit?
Yeah, I heard it.
Okay.
See, for example, when you take plumbing into consideration, the type of faucets you use, simple, there should be water-saving faucets. There are now waterless urinals have come into the picture. Very efficient closets have come into the picture. Water-efficient gadgets have come into the picture. And this is what, for example, recycling of water, sewerage treatment, recycling of the treated all types of grey water, everything comes into the picture. How air conditioning can be reduced to avoid how the entire building can be designed taking into the consideration using passive architecture and taking into consideration the heat gain, heat loss taken into consideration, so that the entire utilization of the air conditioning. What exactly happens? You use more air conditioners, the more greenhouse gases, the more fluorocarbons you pump into the atmosphere, which further leads to the greenhouse gases, which further leads to the global warming. And all those impacts what you saw. So MEP services, electrical, mechanical, air conditioning, plumbing, sanitation, all these complementary services to civil engineering and construction aspects of it, even the landscaping part of it comes into the picture. The higher intensity, the higher spread of hardscape into the landscaping, instead of lesser softscape also is not recommended, because when you have higher percentage of hardscape into the landscaping or in and around the building, that actually reflects more heat. So it is always recommended to have more softscape area around than the hardscape. So all these complementary services, including MEP services, will aid in designing a sustainable development.
Okay, sir.
Did I make it clear, sir?
Yes, sir. Yes, sir. And sir, one more question.
Yeah, please tell me.
What are the measures government are taking to control CO2 emission?
A lot of efforts, lot of policies have been initiated by the government, and it is unfortunately your questions should have, to what extent have we as the population, as professionals, as engineers, as senior citizens, as responsible citizens of the country, what steps have we taken? As engineers, and then we claim nation builders, what steps have we taken to make our buildings more and more sustainable? What steps have we taken to bring the awareness about sustainability to the more this thing? Suppose as designer, I and you may bring awareness to the client, and then if he doesn't agree to use the recycled steel, and many of the structural engineers themselves are not for using the recycled steel. I mean, there is a great amount of awareness that has come into the picture, but I know a couple of, quite a few structural engineers who don't want to use recycled steel. There are quite a few people who are still not responsive to concrete that is mixed with other replaceable cementitious material. So what is important is not the government rules. Suppose if the building, how many of us have we really gone through the building, National Building Code 2016, Part 11, approach to sustainability? Very exhaustively it deals with the entire sustainable construction principles. How many of us have really gone through the entire thing? So it is not what is important is not what efforts or what steps government has taken, what steps as engineers, as nation builders, as citizens, as responsible citizens we take, and then we make this implementable and then fruitful.
Okay, sir. Thank you so much, sir, for giving RPS.
Yeah, thank you for being frank.
Sir, excuse me, sir.
Okay.
Hello.
Yeah, please. I leave it to the moderator, sir. Whatever time you say should close it, we can close it.
I think we'll take another 5 minutes. There are a lot of questions that are coming in.
Okay.
I think we can go ahead.
All right. Okay.
Yes,
yeah,
ma'am. You can go ahead.
Ma'am, please tell me.
Sir, this is Terminologies from Government College of Technology, Bengaluru. I am a civil engineering. And for your answer, I agree with you, but the clients also should come front now. I agree with you, ma'am. I agree with you.
Yeah, that is the challenge in front of us.
Yes.
See, there are lot of professionals, lot of industries, lot of organizations who actually, and there are a lot of clients also who actually have come forward, who have implemented these things. See, for example, many buildings, many people come forward and then try to want their buildings to be rated now. Okay, you have heard of green building ratings.
Yeah.
Green building ratings is one of the aspects of this sustainable construction or sustainable buildings. Okay.
Yes,
But all these green building ratings actually have got their own limitations in the simple reason that all green building ratings are criteria based in the sense that they have criteria. If you do this, you get so many points. If you do this, you get so many points. Okay. If you don't do this, you don't get points, right? So you may get only from instead of platinum, you may get some other lower rating. But what is more important, this we need to actually integrate. But this is, I don't say anything, we need green rating system. We need, at least it is bringing, at least we have started, even at least by way of following the criteria, we have started our journey towards sustainable development. Okay, but these now we have reached a stage where green building rating criteria have to be integrated with actually the design aspects what we talked about, and not only design aspects, and how do we actually try to reduce the carbon footprint, how do we mitigate, what are the challenges we come across, how do we incorporate that into the real design. And we will, one of the sessions is that is coming up is about the sustainability assessment part of it, which you will understand. I'm sure you are going to attend all the 10 sessions, which a lot of information you will get it, ma'am. But we are taking a small step. There are majority, what is important is try to bring awareness so that at least few percentage, there are many builders, many developers, many structural engineers, many architects, they are following this sustainability to a very great extent.
Yeah, thank you, Dr. Ajit Sabnis. And I thank all of you for the active participation in today's webinar. I now request Mr. Shrikant Chanal, Secretary, ACCI Bengaluru Center, to propose the vote of thanks. And I look forward to seeing you all next Saturday, 3rd of October 2020, for the second presentation of Sustainable Engineering Series. Mr. Shrikant Chanal.
Good evening to everyone. On the outset, it was a fantastic lecture by our own Dr. Ajit Sabnis, and we are learning new things on sustainability engineering, and we are happy that so many people, so many students, so many practicing engineers, somebody from Jammu called, and across the India people have been very eager to know the things. And Bangalore Center, in fact, is the pioneer in disseminating the knowledge to all the concerned, and it is always our endeavor to do the dissemination of the knowledge with this regard. And this pandemic, I think, in the other way, thank you for the pandemic, because it has clubbed many areas like Coimbatore, Hyderabad, then Jammu, then Indore. Many people have come and joined our this thing. It is a very encouraging this thing, and I feel that all this coming 9 series will benefit to a larger extent to all the engineering professionals and students basically. Thank you very much for all the participants. And in the next week, there will be another fantastic lecture by our Dr. Ajit Sabnis. And we will take the other issues, other further things, and we'll continue. Thank you very much for all the participants. And thank you, Dr. Ajit Sabnis, sir. Thank you, Mr. D. Ranganath, sir. Thank you all. Good night.
Thank you, moderator, Ranganath, the entire team of Bangalore Center, and all the participants. Thank you very much. Looking forward for the next very informative session once again. Please do participate and encourage and support the initiative taken up by ACC, Bangalore Center, and also ACCI Institute. Thank you very much.
Thank you very much, sir. Thank you.
Thank you. Thank you, sir.
Thank you, sir.
Rangnath sir, can I leave?
Yeah. Thank you, Ajit.
Yeah. Thank you once again. Thank you all.
Yeah.
Thank you, Mr. Rangnath.
Thank you, Mr. Chairman.
Bye.
That was a good presentation by Dr.
Yes.
Ajit.
Thank you, Diksha.
We got to learn a lot of things. It's a good introduction for us also.
Okay. See you on 3rd.
Okay, sir. Thank you, sir. Thank you.
Sir, I have a doubt, sir. Sir, since it is a credit course, do you want us to fill up some feedback form or something like that? Is there anything of that sort?
What is that?
Since it is a credit course, do you want us to fill up some feedback form or something like that?
Yeah, that will be told in the further
In
class.
the end? Yes.
Later
sir.
on.
Okay. All right.
See, minimum of 7 presentations should be attended to by the participants to get the this, and only if you attend at least 70% of it are you going to be considered for getting the credit.
Yes, sir.
Preferably all the 10 would be very good without any
No, even we want to attend all 10. No, but generally at the end of such sessions, they do ask for feedbacks in order to ensure that we have actually attended. So I was thinking that something will a pop-up will come wherein we'll have to fill it up. So I just wanted to clarify.
Yeah, this is just the initial presentation. As we go through the thing, there will be certain aspects that are going to be done by the association, which will consider all these things. Because we have to forward it to the ECI also for getting the credit.
Yes, sir. Thank you so much, sir.
Thank you.
Thank you. Good evening. Bye.
Good evening.
Diksha, you can take the snapshot of all the attendees so that will help you in your list of attendees for preparing your CPD certificate. Thank you.
Yeah, participation list automatically generated through the Cisco WebEx platform.
Excellent. That was the answer that I think the student was asking. Thank you so much.
Yeah, thank you, sir.
Thank you, Rangnath sir. Excellent article.
Thank you, Girish.
Rangnath sir, can I speak?
Yes, sir.
Sir, just one request. Like I've seen the list of topics that are being covered. I think there is a missing information in the sense connected with the transportation engineering, especially highway engineering. Sustainability is going to play a major role in highway engineering also. So please.
So what you're saying is highway is not part of this particular series. Is that what you're trying to mention? Was that you, Mr. Nanjan Swami, who just raised? Hello? I think he's not there, huh?
He muted himself.
Who's it?
Okay, sir.
Nanjan Swami,
I think. Nanjan Swami.
Yes, sir.
Yeah. What you were mentioning was you would have preferred to see highways also under sustainable engineering. Is that what you mentioned?
Yes, sir. That's true. That's true.
We will pass it on to our project leader, Dr. Ajit Sabnis, about it. I'm sure.
Sure, sir.
In the future, things are going to be taken up. This is just the beginning, and we are trying to cover most part of it. And we will continue our discussions and interactions and make sure all of civil engineering is covered in this.
Definitely, sir. Thank you. Thank you very much.
Thank you very much.
So nice of you.
Sir, S6 by one engineer K. Rajkumar is going to speak on role of alternate materials in reducing the carbon footprint. So that will cover most of the things what he has raised, sir.
Highways.
Okay, sir. Okay, fine, sir.
Is it going to be on highways?
No, it is buildings, but materials are there, alternative materials.
Mr. Nanjan, I think Dr. Ajit Sabnis is here. Can you put forth your question to him now?
Okay, sure, definitely.
But it's not yet ended.
Sabnis, sir.
Okay. Hello.
Yeah, Mr. Swami.
Hello, Sabnis.
Yeah, tell me, sir.
Sir, this is Nanjan Swami from JCE, Mysore.
Oh, yes, sir. Tell me. How are you?
How are you,
good,
sir?
Good. Tell me.
Nice, sir. Sir, one request is like all the topics, whatever is mentioned in this series is related with building.
Related with building?
Buildings.
Okay.
Okay. So can anyone can speak on sustainability related to highway engineering or in general transportation engineering? Because highways are consuming quite a lot of aggregates and fuel and so on.
Yeah.
So obviously they are actually imparting a lot of impact on our environment.
Okay. Like this, the 9 sessions will also address a part of the civil engineering, other infrastructure projects. Okay. Now, actually, overall, if you understand, urban scenario is the most importantly and then primarily to be tackled. That is where actually the sustainability issues are not in the rural areas. Sustainability issues are more in the urban scenario. And our urban contribution to the impact of sustainability is extremely high when compared to the infrastructure projects and, for example, even the road projects. Okay. Now, we will take the, infrastructure projects along with the buildings also will be considered, will be taken up in the upcoming series. So basically, when we talk about materials, what exactly could be the alternative materials for roads, whether any other recycled aggregates is possible to be used, all those things actually, and actually one of the important things that is coming up is also, how do you actually calculate the embodied energy for the road surface?
Yes, sir.
Nobody talks about it, nor the college, any college or anybody gives it as a project or the MTech project for identifying, these are one of the most important things. How do you calculate embodied energy for the road? So you need to understand first what exactly is the construction matrix of the road, what exactly is the cross section of the road, how do you construct the road, what are the types of equipment that are used in the road. Unless you understand those things, it is extremely difficult to understand, to arrive at what is the embodied energy impact, what is the embodied carbon impact on the infrastructure projects. Let us say highway projects. So we need to discuss all those things and then understand, just talking about the impact of highway construction on this thing, generally it can be talked. But what is ultimately important for we as engineers is, how do you quantify it? How do you understand the figures? And how do you mitigate them using the figures? How do you prove ourselves that we have reduced? And we as engineers, we should talk only numbers. We can't talk only theory or the subjective part.
That's my point. And there is what you said, like a green rating for buildings.
Yes.
On the similar lines, there is a green rating for highways also, sir, nowadays.
Yes.
Published a codal provision, a guideline on that aspect also.
True.
So if that is also covered, I think
it will be covered, sir. I think, there is a talk on all the documentation, codal provisions, and then which are, there are no codes as such specified, but whether it is a national building code or it is the energy conservation building code, all these important codes and then guidebooks, manuals, etc. will be, there is one exclusive session by Dr. Raghunath, who is going to touch upon all these things on the guiding principles.
Fine, sir. I'll talk to him, sir. Raghunath, I know personally.
If you talk to him, ask him to include also these things in his presentation. That will be helpful for others also.
Definitely, sir.
Yeah, good. Yeah.
Thank you very much, sir. So nice. Sir.
Thanks. Thank you so much.
I think we can end. We still have 55 participants on the platform.
Oh, I see. What was the total participation?
205.
205.
Yes, sir.
Okay.
But registration crossed 700. 30% only joined.
Yeah.
Maybe,
that's good.
Yeah. Maybe they will all join next week.
Let us see. Oh.
Yeah, we'll see. Okay, then I think we'll close. We'll end it. I'll close the meet today.
Yeah.
Recording, should I close it?
Yes, sir. Yes, sir. Yeah.
Should I close it or if I end it, it will automatically go?
End it, sir. It automatically generates.
Okay. Okay then. See you all.
Yes.
Thank you.
Thank you, sir.